Hello everyone, welcome to our video on solving inequalities. Most of these you have done before, but this will be a nice little review and a good introduction of how the videos are going to work this year. So our just basic inequalities, like this number 1 and 2 here, all you have to do is just perform operations on the function on both sides of the equation, inequality, just as you would do on an equation. So for example, in number 1, since 14 is being added to x, we just subtract 14 from both sides, and we end up with our solution set as x is less than negative 15. And of course, we're going to be writing our answers in interval notation. So x is less than negative 15, so our lower bound here is negative infinity, and our upper bound is negative 15. So on the next screen, you'll have to input your answer in interval notation for question number 2. Now, with compound inequalities, we have two different options for this. We have ones that look like 3 and 10 here, where the compound inequality has the variable in the middle of two different quantities. So it's bounded by those two quantities. So, or you could have it where you have two separate ones. So for something like number 10, what you have to do is perform operations on each piece of the inequality to get the variable by itself, very similar to what we're doing with an equation, just we have 3 different locations that we're performing this on instead of just 2. So for example, we need to subtract 6 from each of these, and then we have negative 56 less than 7k, which is less than negative 14. Then, to get k by itself, we have to divide by 7, but we have to do that on each piece of this compound inequality. So, we end up with negative 8 is less than k, which is less than negative 2. And then, of course, we're writing this in interval notation, so k is between negative 8 and negative 2. It's going to be slightly different for when we have problems like number 4 here. What we have to do with this is look at the two separate intervals and work with them on their own, and then our answer will just include both intervals. So let's change up the color a little bit. So for this piece, what we have to do is add 2 to both sides of the inequality. So we have 10a is less than or equal to 40. Divide both sides by 10. And a is less than or equal to 40. We're also keeping this or here because it's this or whatever is happening over here. So what we have to do here is add 5 to both sides. So we have negative 4a is less than or equal to negative 24. Now, this is something that provides an opportunity where common mistakes are made. So when we divide both sides by negative 4, everything with our constants will change just like you think it would. So negative 24 divided by negative 4 is 6. But instead of a less than or equal to, whenever we multiply or divide both sides of an inequality by a negative number, we have to switch the inequality. So we end up with a is greater than or equal to 6. So what happens here, sometimes we will end up with 2 separate intervals. So say we were graphing this on a number line. So sometimes we would have something like a was less than or equal to this, and then greater than or equal to this, and we'd have two separate intervals. In this case, if a is less than or equal to 40, and then we've got it greater than or equal to 6, that fits onto one interval. So we'll use brackets because it's a is greater than or equal to 6, and then brackets again because it's less than or equal to 40. So for your next question, you'll have to put the solution set in interval notation for number 3. Now, we need to work with absolute value inequalities. So what we do here is first get the absolute value symbol by itself. So here we have to subtract 5 from both sides. So we have the absolute value of p divided by 8 is less than 1. Now, in previous courses you might have looked at this, or if you're remembering from like doing it with an equation, you just go, oh, well, we've got 1 and then we've got -1. But what actually happens is our first half is that p divided by 8, that whole argument, so what's in the absolute value, is just going to be placed there normally, and we'll just have p divided by 8 is less than 1. But then what we have to do is take the opposite of the argument, so negative, and then the quantity p divided by 8 is less than 1. The reason that's important is because then when we divide or multiply both sides by -1, it will cause this inequality sign to switch from a less than to a greater than. So we end up with p divided by 8 is less than 1, p divided by 8 is greater than -1. So we'll multiply both sides by 8, so p is less than 8. We'll multiply both sides by 8 here. P is greater than -8. So since we have p is less than 8 and p is greater than -8, we end up with one interval for our solutions, which has -8 as our lower bound, 8 as our upper bound. The last question for this, which you'll have to do, is write in the solution set for number 6. Thanks for watching.